Hey, Gildy, Fletch here. Today I'm going to be talking about Programming 101, episode number 2, which is going to be talking about types. What does type mean? When are types looked at? How does your programming language use types and things like that? So stick around and we'll talk about types. All right, so type means essentially the kind of data that your program is using. You can imagine one type that we talked about in the last episode, which is a numeric type. And that type is something like 100 or 10 or 35 or some other sort of number. These kind of types can be more nuanced. There can be a lot of different types of numeric types, types that have decimal components to them. They can be negative or positive, and all kinds of different ways that integers and decimals are used. I'm not going to get into complexities of floating point and everything, but there's mathematical complexities that you can do with numbers. You can do addition, you can do multiplication, and all the different types of mathematical operations. The other kind of type that is most common is the string type. And a string essentially just means words. It's what you would find all of your documents written in. This is what my document says, and it's text, lol. So it's something like that. So a string is a continuous string or connection from character to character or letter to letter, and it can look like this or it can look like this. This is still just words. You could say 80 times I like to fly or something, whatever you want to put. So of course, letters are characters just like numbers are characters just like letters are characters. So this is a string and it's surrounded by quotes. So quotes means it's a string, which is a series of characters, or it's text that is a series of letters and numbers and symbols like that. The last kind of data type that's important to know is Boolean. And Boolean just means true or false. Again, there's more complexities you can get into that, but true or false essentially means 0 or 1, where 0 would be false. It means nothing, not there, not good, false, empty. 0 means nothingness, that's false. And 1 means true, success, good. That's it. So there's really only two values for Boolean. There's other complexities you can get into with it, but I'm not going to go into those right now. So this is a Boolean. Is Sue happy is true. This is a number, which is 50, and this is a string, which is 80. It says 80 as the string, but it really means 80 like I'm saying 80 to somebody. This means 50 as in an actual number that represents an amount called 50. And this is just a string that says 80. So those are types. And now I'm going to talk about another thing about programming, which is going to be very important to know based on your programming language. And that is something called design time versus runtime. This is design time. This is me designing the code. It's writing the code. I'm debugging the code, looking at the code. Anytime you can see and mess with code and change code, that's design time. I'm designing the code and I'm doing stuff right now. And then there's runtime. Runtime, as I showed a little bit last time, if I hit run or debug or I execute my program, it's now running. It's now a runtime. So everything that's happening is actually running. You can see a difference because in design time, if I put my mouse over age of Joe, it just says, yeah, that's a variable. It's a variable called age of Joe. We're expecting it to be a number there. Okay, there's a number called age of Joe. It doesn't say that it's 100 though. I mean, you can see here that I've written it's going to be 100, but since the code's not running, there's no actual value assigned to it. It's just, this is what I'm expecting to happen when I run my code. Now, when I run the code and I'm in runtime now, I put my mouse over it, it says age of Joe is 100 because it is 100. If I put my mouse over age total, it so far hasn't gotten there. It's undefined. There's nothing there yet. So we haven't yet gotten down to that point. Now we've gotten down to that point. We haven't run it yet at this point, but we've gotten to that point. So is Sue happy? That's true in it. Age of Sue has been changed to a string called 80, etc. So design time is when you're doing things here in the IDE and you're writing code, and runtime is when your code is actually running and then the values get assigned and the operations happen. So that's design time and runtime. So let's go back to types. And I told you this is a numeric type. This age of Sue is also a numeric type. But then I change age of Sue into a string. And so this is going to be very important for the word dynamic. Languages can either be dynamically typed or statically typed. What that means when you say dynamically typed is that at design time, when you're here typing your code in here, it doesn't really care. Let me click over here for a second. It doesn't really care what you're doing with your variables. Sometimes it can get a little bit finicky, but for the most part, you're saying it's 50, it's a string called 80, and it'll figure it out when it gets to the runtime. So in here, age of Sue doesn't even exist. I'm telling it some instructions, but age of Sue doesn't really exist. It's not compiled and it's not running. But when I'm running the code, let's put the breakpoint here. When I'm running the code, age of Sue is a number that says 50. So now that I'm in the runtime, it says, okay, age of Sue, it's a number. And from then on, it's going to be a number until someone changes it. Okay, we're changing it right here to a string that says 80. Now, from now on, until someone changes it again, age of Sue is a string. And so dynamically at runtime, it says, I'm going to be this thing. This is my type. I am a string. Age of Sue, the variable, is a string now and forever until at some point someone goes in and changes it. That's at runtime. That it determines what the type is at that moment in the code, in the runtime, while it's running. So I can't tell it here. There's no way to say integer or number or something like that. There's no way to tell it what it's going to be and say it has to be this, and I can expect operations to work in design time so that I can get some sort of feedback on that. IDEs are pretty smart these days, and they can sort of tell. They can sort of tell what it's going to be, but the design time doesn't care. And I'm going to contrast that with over here in C#, which I'll talk about here in a second. It cares. If it's an integer, it's an integer. You can't change it to a string. In design time, you can't change it to a string. So here, I can change it whenever I want in design time, and in the runtime, it'll decide what it wants to be when it gets to that point. If it gets to that point, then it'll change the type. Then there's weakly typed versus strong typed. What that means is the way that it's executing the code, the way that it converts between the different types. So if you have a weak typed programming language like JavaScript, then what you're going to do, what you're going to see is something like this. This is a little bit of an equation here that says age of Joe, which is definitely going to be 100. We only assign it up here to 100, minus the age of Sue, which is a string called 80. And you can't really subtract a string. Like if I say, ha ha, ha ha, what's 100 minus ha ha ha? As you can see, since it's dynamically typed, it's not even going to give you an error here when you're designing. And since it's weakly typed, it's going to try to say, well, what does ha 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 mean? Maybe we can subtract 100 from ha ha ha. It's not going to work, but I'm going to skip past that. So we're going to put it back to 80. So what that means for a weakly typed language like JavaScript is 100 minus 80, and the language is going to say, I recognize that string. That's a lot like 80, the number. So it's actually going to subtract 80 from 100. And so the answer will be 20. Similarly, the Boolean here, which is either true or false, it'll say, oh, well, that's true, which I recognize can also be a 1. So I'm just going to implicitly, which means it's sort of like automatically without telling anyone, I'm going to convert is Sue happy to a 1. So this will be 100 minus 80 minus 1. So let's see how that looks. Bam. 19. 100 minus 80 is 20. Minus 1 more is 19. 100. This is a string called 80. You can see the quotes around the outside. And is Sue happy? It still says true, but that evaluates as a 1. So this is weakly typed. It'll just change what you're doing in your code based on what it interprets it wants it to be. And it'll implicitly convert it, if it can, to something else that it wants it to be. Now, let's see what happens when we use the plus sign. What is age of Joe, 100, plus age of Sue, which is now 80 as a string, and is Sue happy, which is 100? What? What? That's not right. I was expecting 181, right? But what it does is it says age of Joe. Okay, that's a number. Age of Sue. Oh, we're talking about strings, and this is something that hey, neat things. This is things. This is just a Programming 101 tutorial. This is episode number 2. It's just talking about types. So it's going to be pretty basic, pretty high level. So the concatenation, the plus sign is something that you need to look out for in any programming language. Obviously, it can mean addition, but a lot of the times it also means concatenation. And that would mean that if this said hello, and this said world, stop, save, run, then you're going to get hello world. And we still have that true on there, so it just evaluates that as true. So concatenation just means take some string and some other string and just put them together. So the plus sign you sort of got to look out for a little bit. But a lot of times it can mean concatenation, and a lot of times it can mean addition. And that's really scary in a weakly typed language, because if it's weak typed, then you don't really know what the plus sign is. Luckily, that's only a problem for the plus sign. Division and multiplication and such would definitely work differently. So now it's saying age of Joe, 100, times 80 divided by 1, which true is 1, then that equals 8,000. There you go. So the plus sign is the scary part of that, but you have to be really careful in a weakly typed language. So JavaScript is dynamically typed, which means it decides what those values are, what the types of those values are while it's running, not while you're in design time. And it's weakly typed, it's weak typed, which means if you're doing operations on the different values, it's going to decide at that moment how it's going to be using those values and what those operations are. A little bit scary. JavaScript is a very scary language to work in. You have to be very careful. It's also very powerful. But so that's JavaScript. I'm going to talk about Python a little bit. One moment. Okay. So Python is dynamically typed, which means it cares about what these are while it's running. It'll decide what those types are while it's running. And it's strong typed. So let's talk about that a little bit. Let's just go ahead and run it. I need to turn that on. Python, set as the startup project, start. Okay, so this is the Python. We have age of Joe, and we say we want age of Joe to be 100. So age of Joe is 100. We want to have age of Sue. We want age of Sue to be 50. So age of Sue is 50. Okay, I changed my mind. Age of Sue, we want it to be a string called 80. Okay, we're going to change that to a string called 80. So now at this point, since it's dynamically typed, everything from this point forward is going to treat age of Sue like it's a string called 80. All right, is Sue happy? True. Yes, Sue is happy. And what is the age total? So the age of Joe is 100. The age of Sue is a string called 80. And is Sue happy is a Boolean called true. Whoa, exception. This is what strong type means. It's not going to implicitly, magically, just out of nowhere without telling you, convert that string into a number. It's not going to look at that and say, okay, that could be an 80, that's a number. It says that's a string. I'm not going to mess with that. If you meant for that to be a number, then you need to put something in here that says, essentially parse that string into a number. You need to make that a number for me. So this says exception thrown. Ooh, I didn't know that moving around would do that. Anyway, unsupported operand types for the operation of subtraction. So for the operation of subtraction, you can't have an integer on one side and a string on the other side, is what this is saying. So that means it's a strongly typed language. So let's go ahead and comment this out. In Python, the comment is the pound sign. I will run it, and we will see that we have age of Joe is 100, age of Joe is 100, age of Sue is still the 50 number now. It's no longer the string, and is Sue happy is true. It's a Boolean called true. So what's going to happen? Surprisingly, it still works. The reason why it still works is because a Boolean in Python, its actual underlying type is a number. So really, it's just strings and numbers are the most primitive types. It's more complex than that, but the most primitive types in Python are just strings and numbers. And a Boolean is truly just a number. It's either a 0 or a 1. So it's going to treat that as 100 minus 50 minus 1, because true means 1. And so, of course, age total is going to be 49. And now I'm going to change age of Sue back to a string of 80, and I'm going to concatenate. Now, when I concatenate, again, this is a strongly typed language, the first number I have here is an integer, and you can't concatenate integers together because integers aren't strings. When you concatenate, they have to be strings. So unsupported operating types for the concatenation plus symbol, you can't have an integer and a string. It's got to be all strings. So, of course, that's going to throw an exception. So that's what strong means. A strong typed language means that it's not going to implicitly just convert values around for what it thinks they need to be. And there's a lot more than just concatenation where this gets into. There's going to be calling other code and bits of code over here and things called functions and moving things around. It's not going to just implicitly assume that what you mean was to make that a number, or what you mean was to make that a Boolean or a string or something like that. Now, in the design time, it's not throwing any problems. It's not saying, even though we see right here, I'm clearly making this a string, and this is clearly an integer. At design time, it's not giving me any problems. And when it compiles, it's not giving me any problems. It'll compile just fine. That means it's a dynamic language. It's dynamically typed, so it'll decide these values, and it'll throw whatever exceptions at the time that it's running instead of at the time that it's compiling. So here you go. Everything works perfectly fine. Everything compiles. It's dynamic. But it doesn't do the work for you of just converting it to the values you want to. So this is a strong type language. You can see that in C#. It's a very, very visual thing because C# is a static type language. What that means is that it's going to, it doesn't mean it's going to give you errors at design time exactly like I've been saying. It just so happens that most IDEs take the errors that happen when you compile the code, and it's very nice to you, and it says, when you compile this, there's going to be a problem. So if I were to try to make this into a program that I'm going to then send to people that they can run, that's called compiling it. I'm compiling it into an executable program that I can then give to people. They can install it on their machine, or they can run it on their machine. That's when the error really happens. But at design time, it says, I know that when you compile it, it's going to be an error. You're not going to be able to run this. You can't compile it. You won't even get to the runtime. So it says, I know this is going to be a problem, so I'm just going to tell you right now, this is going to be a problem. That's because it's a static type language. It is also a strong type language. So I can also say, that's really all there is to it. There's not that much to talk about after that. But let's go ahead and take a look at how we make this work. So age of Joe is a number. Age of Sue is a number. Is Sue happy is a Boolean. So that's just not going to work. Okay, there you go. Now I'm not even using is Sue happy, but it doesn't make sense anyway. If I want the answer of a the difference of ages, then the age of Joe minus the age of Sue, that makes sense. Minus a Boolean doesn't even make sense. So those errors had made me look at my code and say, oh, whoops, I'm subtracting a Boolean. That's not what I want to do. And now it will actually run. Oh, I need to change the thing again. Set a startup project. There we go. So age of Joe is 100. Age of Sue is 50. Is Sue happy is true. And the answer is 100 minus 50, which is 50. So C# is a statically typed language. It is a strongly typed language. Python is a dynamically typed language and a strong typed language. And JavaScript is a dynamic typed language and a weak typed language. Another thing that we learned about this today is that there are essentially three primitive variable types, three primitive data types. Numeric types, which could be a whole array of nuanced stuff that I'm not going to get into right now, but numeric types essentially. String types, sometimes it's also a collection of character types. You could say this is a collection of many characters. So maybe character is a type, but essentially characters or a set of characters that string together to create words. Characters that string together to make words and sentences and such. That's called a string. And Boolean types. These are the main underlying primitive types in programming. And you can do all kinds of operations with them. Definitely mathematical operations, but we're going to get into more fun operations in the next video. Before I leave this one, I'm going to answer a couple questions that I wrote down from the last video. So question or observation number 1 that I got from my last video is this is in the voice of the person asking the question, when I imagine programming, what I imagine is this. Oops. Like they imagine this, a console application or a CLI where it's just a command, and you're typing these commands and it's doing things. You're doing netstat and you're doing connecting to different people's, and you're hacking essentially. This is what people imagine as programming. And I think it's surprising to this person who's making this observation, surprising to see that programming is, I think, using plain language for the most part. You're able to put real words or make up words that you want to. And it's using this fairly nice application or any fairly nice text editor where you can see what you're doing. And it's not a CLI or a command line that's doing really complicated looking nerdy stuff. Or imagining it like this. This isn't what programming is, but this is, I think, how a lot of people see it before they really start getting into these basic tutorials. They think, this is programming, which, yeah. But this is programming. Programming is pretty much regular English words with some basic math operations, and we're going to get into some other syntax later. This definitely looks weird. We don't write semicolons a lot in English. We write semicolons sometimes, but a lot of languages have, especially C-style languages, which is a whole different concept. They end with a semicolon. That just means that's the end of what I want to do for this line. Some of them don't. I'm pretty sure you want in JavaScript, you don't have to have semicolons. You can, but you don't have to. So there's a lot of weird things that look like that you can see in programming, but after you get past the idea that it's a command line interface or like where you've got a CLI up and you're typing these weird commands in and then a bunch of text is zooming by you and someone's like reading it really fast and they're just hacking away. It's not like that. It's nice and slow. It's like this tutorial. We just go through one thing at a time. We just write some real words. That's pretty much what programming is. Another one is, what are some common repetitive things that you do in programming that I should aim to master as a beginner? I think you'll come to find in the next few episodes that this is the repetitive thing. You create variables. In further programming, you try not to change variables. You try to not mutate them. You try to keep them what they are. But this is pretty much what it is. You make variables. You make a new variable that represents the difference of ages, and you use that somehow. You just use these variables. There's ways to do these things over and over multiple times, over and over and over and over in a loop. There's ways to segregate your code to say, okay, well, this is how I do ages, and this is how I do heights, the different heights of people. You can segregate your code to make it more easy to understand. So there's a couple different ideas, But this is pretty much it. This is the idea of programming. The things that you want to get used to is just understanding the syntax. Do you start with var? Do you end with a semicolon? Are you allowed to say what your types are? Right. I meant to say this one for semicolon. Are you allowed to say what your types are? These are those types of syntax that you really want to sort of understand. And when you master that, it starts to get really, really easy to understand these things. And then the other one, how do you give yourself goals that will help you engage with learning programming? So if you want to learn programming and there's a spark and there's some interest, and I want to learn programming mainly because it maybe it just excites you or it confuses you and you want to just know how computers work and how they work under the covers, under the hood, then what you need to do is come up with something that you actually want to happen on a computer, something really, really easy. One of the things that one of the first programs I ever wrote was what we call a MUD. And what a MUD is it's essentially one of these. It's a command line interface where you can say, I am Jeff, and then hit enter, and now you're Jeff. And you can say, where am I? And it would say, you're in a room that's full of magic. And okay, cool. And you can say, look around or something like that and say, oh, there's a door to the north. And you can say, okay, there's a door to the north. Go north. And then your character would move north. And you can make this map and you can make different interactions with the map. And it's purely text-based and the text would tell you things. That's a really fun first program for me. Another really fun first program that you can do is just a calculator. I mean, this is just a calculator, but maybe you have more complicated calculations that you have to do. So you can make calculations that are doing solving polynomials or something like that. So these are things that can help you with your math homework. Of course, there's online things you can do, but if it's something that you need, you could go online, or you can say, I'm going to use this as an opportunity to learn how to program it. Because obviously, programming math is really easy. You just put something in there. So these are sort of small goals that you can do. Let me see some other things here. Set timed goals. You can do things also like Advent of Code. Look for Advent of Code, adventofcode.com, and you can do these programming challenges that essentially say things like, let me go to here. Maybe I'm not logged in or something. So this is a fun little story. It's a really fun challenge. And this is about Christmas. Advent of Code is like a Christmas calendar for the first 25 days of December. And each day has 2 challenges. And so you have to solve this challenge. It gives you a little bit of input, for example, like this. And you have to solve how to figure things out. And it's a basic math problem. You figure it out, you get to a distance of 11. And it'll give you different inputs. And you need to write a little program that does that. And this is a fun challenge that if I were logged in, you would see mine. But it'll say you completed a star for day 1, and then you completed 2 stars for day 1 if you do the second challenge, and then day 2. And you can't do the next one until you finish the prior one. It's really finished. There's also things like Code Golf, which is just fun little challenges that you just do some programming, and it'll really help you learn the syntax and learn how to do your programming. So that's another answer to the question. Anyway, this episode has gone on quite long compared to my last one, but I hope it was really informative. I hope you learned about types, especially the different types of languages, static and dynamic, or strong and weak, different types of languages, as well as the 3 main primitive types, numeric, strings, and booleans. We'll go into how to use these types a lot more, how to segregate your code, and how to do a lot more fun things in the next episode. So I hope you come back, like and subscribe, leave a comment, ask questions so I can answer more questions for the next video, and I'll see you guys next time.